Hello everyone, my name is ZHENGHAO. My magical number is 208967. This is graph models. Graph models, graphical representations of probability distributions are called probabilistic graphical models. A graph is composed of nodes and links between them. Graph model belongs to structure model, which can be used to describe a large number of things and the relationship between things in nature and human society. Graph model can be used as a tool in modeling analysis according to the properties of graphs, provides an effective method for studying various systems, especially complex systems. The graphics that make up the graph model are different from the general geometric graphics. The following examples are all common things in life, indicating that graph models is inseparable from our lives. Common graph models. This picture shows the relationships diagram of the more common graphical models in life. This is example is a question. This is explain. This question illustrates the relationship between each element and they are interrelated and restrict each other.
Hello everyone, my name is ZHENGHAO. I will talking about isomorphism. In mathematics, isomorphism is a structure preserving mapping between two structures of the same type that can be received by an inverse mapping. Two mathematical structures are isomorphic if an isomorphism exists between them. Isomorphism is a very general concept that appears in several areas of mathematics. Formally, an isomorphism is a bijective morphism. Informally, an isomorphism is a map that preserves the sets and relations among elements, and have a types. An isomorphism from a set of elements onto itself is called an automorphism.
Good afternoon. My name is Li Yuxuan and my metric number is 204920. Today I will talk about the topic graph theory, edge counting. About this age counting, I will show us some examples about different graphs. First graph, I want to talk about the complete graphs. As we all know, complete graphs, we always use Kn. N is a variety about a graph. So we use this formula to calculate the ages. So for example, when Kn equals 4, the age, use this formula, we can know the age equals 6. So use this formula about the complete graph, we can know the n equals 5 or n equals 100, or we can use this formula about the complete graph. So now, second, I want to introduce a bipartite graph. About bipartite graph, we have two kinds of graphs. One is a common bipartite graph. Is like this. So about this picture, we just can count one by one. So about this picture, the age is 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 ages. Then we also have the complete bipartite. M equals 5 and N equals 3. So the age is 15. We just use M multiplied 3 is equal 15 is okay. Okay, let's look at the next slide. Is the degrees and neighborhoods of vertices. So how to count the number of edges? First, we look at x. Then we show the degrees first. X, we have 1, 2, 3, 4, and A has 2, B also have 2, C 2, D 2. So so we finish degrees. Then we look at neighborhoods. Neighborhoods X is A, B, C, D. A is X, B is AX, C is X, D is X, C. So when we write it on the paper, we write like this. We cannot write just like x equals 4. No, we cannot. We must use the degrees first. Write like this is okay. Then we look at the in degree and out degree. So in degrees and out degrees. So first we think about the in degree is negative, and the out degrees use plus. It's okay. So we look at the first is A. We can clearly say that A has 2 in degree and 2 out degrees. Then we look at C. Its in degree is 2 and out degree is 1. Then we look at D. D is a loop, right? You think about the only one in degree is not correct, because it has a loop. If the loop has in degree and out degree, so the in degree is 1 and the out degree also is 1. So let's look at B. So we can clearly now has 1, 2, 3 in degree and 1, 2, 3, 4 out degree. So this is about in degree and out degree. Then we look at handshake theorem. About handshake theorem, especially if J is any graph and the vertex of J are V1, V2, point, Vn, where n is non-negative integer, then the sum of the degree of all the vertices of J equals to twice the number of edges of J. So we use this formula to calculate edges about hand-shock theorem. Let us see the example. Example: how many edges are there in a graph with 10 vertices of degree 6? So we look at this formula. Can now we use 10 vertices. 10 vertices multiplied 6 degree is equals 16, and 2 edges equals 16. So we can now edges equals 13. This is about hand-shock theorem. Then we look at the very popular and famous question: seven bridges. Is it possible for a person to take a walk around the town, starting and ending at the same location and crossing each of 7 bridges exactly once? Of course, so many people think about that is no. This is about this is all the edge countings. So I use lots of different graphs to show how to calculate edges.
Hi, Assalamualaikum. My name is IRFAN bin Abdul Rahman 206847. Today I wanted to explain about what is planar graph. Okay, planar graph is a planar if it can be drawn in the plane with no edge crossing. Okay, what is meant by no edge crossing? No edge crossing is like this one edge and this one edge. If this is the edge crossing, meanwhile, if not a plane crossing, edge crossing is like this. It's no edges crossing. Like this, plane graph definition. Planar graph that has been drawn in the plane with no edge crossing. Okay, this is a plane graph. This is not a plane graph, but this is planar graph because it can be drawn without edge crossing. Like this, become like this. Okay. Okay, region of graph. An area of the plane that is bounded by edges and cannot be further subdivided. Planar graph divide the plane into one or more regions. Okay, finite region. If the area of the region is finite, then that region is called a finite region. Meanwhile, infinite is contradict with finite, that is infinity region. Okay, let's look at this graph. From this graph, we know that R1 and R2 and R3 is finite region because it's bounded by edges. Meanwhile, R4 is infinite region. So from this graph, we have 4 vertices, 1, 2, 3, 4, 6 edges, 1, 2, 3, 4, 5, 6, and 4 regions, 3 finite region and 1 infinite region. This is another example, and you can see the total region is 6. Okay. Property of planar graph. If a connected planar graph has E edges and R region, then R must be less than or equal to 2/3 edges. Okay, second is if a connected planar graph has E edges, V vertices and R region, then from the Euler formula, it must be obey vertices minus edges plus region must be equal to 2. Okay, third one is if a connected planar graph has E edges and V vertices, but we don't know how many regions, so we use the formula to know it is a planar graph or not. 3 vertices minus edges must be more than or equal to 6. Okay, a complete graph Kn is a planar if and only the vertices must be less than 5. Okay, a complete bipartite graph KMN is planar if and only if M must less than 3 or M must be over than 3. Okay, from the properties, we know that it must obey the Euler formula. Euler formula is this: vertex minus edges plus region equal to 2. Okay, look back at from the same example, the graph. We know that the region is 4, the edges is 6, and vertices is 4. So, by applying Euler formula, is equal to 2. So, this graph is planar and obey the Euler formula. Okay, look at this. This is also the planar graph, and we see that it has 12 edges, 6 region. By applying Euler formula, it also got equal to 2. Okay, non-planar graph. A graph that cannot be drawn in a plane that no edge crossing. Okay, property for non-planar graph is a graph is non-planar if and only if it contains subgraph homeomorphic K5 and or K33. What is homeomorphic? Homeomorphic is both can be obtained from the same graph by subdivision of edges. Look at this. First, it has 2 edges, but it also can have 3 edges. So, both graph is example of homeomorphic graph. Kuratowski's theorem says that a finite graph is planar if it's not possible to subdivide edges K5 or K33. This is a K5 graph and this is K33 graph. Okay, look at the K5. It said that he has 5 vertices and 10 edges. So by applying the property for planar, it not obey the properties of planar. So K5 is non-planar, and also same as K33. By applying Euler formula, it not obey the Euler formula. That must be 2. So K33 is non-planar. Polyhedron is a regular polyhedron that also known as platonic solid because each face is identical regular polygon and each vertex and join an equal number of faces. Okay, this is an example of a cube that we translate into the planar graph. You can see by applying Euler formula, 8 minus 12 plus 6 equal to 2. Thus, a cube satisfies Euler formula for planar graph. That's all from me. Thank you.
Hello everyone, my name is ZHENGHAO. I will talk about applications of graphs. First, the basic concept of graph. The graph studied by discrete mathematics is another kind of mathematical structure, which is different from geometric graph and mechanical graph. It doesn't care about the position of vertex, the length and shape of edge, but only care about the connection between vertex and edge. Graph theory has turned out to be a vast area with innumerable applications in the field of social networks, data organization, communication network, and so on. Applications of graph theory. Graph theory is used in vast area of science and technologies. Some of them are given below. Computer science, electrical engineering, linguistics, physical and chemistry, computer network, social science, biology, mathematics general, and there are 6 problems that can be solved by graph. Topological sorting, spanning trees, minimum spanning tree, shortest path tree, cycles, treating salesman problem.
Okay, thank you for your listening. Goodbye.